Hi everyone, welcome to practical exercise 2. In this exercise, we want to learn about how to specify database schemas using SQL data definition language, and we're gonna know how to define constraints on data. So basically, we're gonna learn how to define primary keys, foreign keys, and a bunch of check constraints, and hopefully we'll learn more about referential integrity and data dependencies, and we're going to learn all of that by playing with the database. So here, this is a background. So this is the diagram of the schema we're trying to implement, and hopefully by this point you know how to design an diagram as well as how to map an diagram into SQL. So basically we got, this is a company database, we got employees, we got department, and we got department mission, we got composite attributes, and we got these underlying attributes, which are basically key attributes. These are their primary keys. And to proceed with this exercise, you need to read through these requirements, and this is the sample data. This is the basically tells you the type of data you want to put in as TFN. So one thing before we get started, one thing we want to understand is that where do we get help? Like, how do we really implement these constraints on the schema? So one thing you look for is one thing you can resort to is the PostgreSQL menu. So this is the gold standard. You always go to here before you ask questions to us. So I recommend you read through most of these parts. And for this exercise specifically, you want to read through SQL syntax, data definition, data manipulation, especially data definition. So let's open up data definition. And here you see that 5.5 constraints. It tells you how to implement the check constraint, not null constraints, primary keys, and stuff like that. So basically, this is where you can get the help from, and you can basically learn from here and then implement that in our exercise. Okay, let's just get started. So first, on the left hand side, you can see that I've already logged into VXDB and have already automatically sourced my environment file. And now what we're going to do is that we're going to create the database, populate the database, load the schema, and test the schema. So first thing, you need to copy these files to your directory. So I feel like I've already done that. So let's go to my local storage folder. Okay, and we can just do that, and then we can just copy all of the SQL files related to this exercise to our end, and we can just basically go to the new folder in the root directory. Okay, here you can see that we got a bunch of SQL files, and all of these will be useful to this exercise. So first of all, what you need to do is that you need to create, so we have prepared the files. Now we need to create a new database to hold the company information. So what you're going to do, it doesn't specify what command you use, but it does specify you need to use the create db command. So basically what you do here is that you create db company. Okay, I think maybe we haven't started the server yet. Yeah, so that's a huge mistake. So we start a server now, and now if we list all of the databases that are there, okay, I think we already have the company database. Let's just drop that. Let's drop db company and recreate it, create db company. And then at this point, if you connect to the company database, it is empty. So first thing first, you want to load the schema into the database. At this point, the schema is a very basic one that does not have enough constraints. So you can load that. And if you investigate each of them, you'll see that we have a very basic schema, because for each table, we only specify the name of the columns as well as the type of the values we put in there, and we don't have any constraints. So for instance, in here, any three characters can be used as a department ID, and for and maybe for TFN it allows any type of characters, but we need them to be in a specific format like we discussed in the lecture. So we want to control the type of data that go into our database, so that our database is a logically coherent collection of the truth. So if you do that, you can examine. After doing that, this will give you a basic schema. And now if you run this query, you'll see that this is empty because none of the valid data has been loaded yet. So what you want to do now is you want to load the valid data into the schema. So you can do that. So this is showing the way to do that in Linux. And as we have discussed, there's an easier way to do this is within the PostgreSQL shell, which is using the \i and followed by the SQL script you want to run. And this will produce a bunch of insert 0-1s. So the 1 tells you that one tuple was inserted, 0 tells you there's nothing wrong with it. So basically at this point, you can examine these tables again, and you see that we have real data. Okay, we have real data, and these are all good data. So if you look at them, you will not see any problems. So they're all legitimate data. Okay, and now the next step is very interesting. So we also have a SQL file called bad.sql. So what is in bad.sql? Bad.sql include a lot of data that does not satisfy the constraints we're trying to impose. Let's get out of the database first and really investigate what is in bad data. Okay, I'm gonna use Vim to look at this. Okay, so as you can see that this is bad. This is bad.sql. So let's look at some examples and see why it is bad. So if you look at employee values, so let's go up to the ER diagram and see for employee values, it should have a text file number. It should specify the name, family name, given name, as well as the number of hours they worked, right? And you can see that there are a couple of things that's wrong. There's a couple of things wrong here. So first of all, the text file number should be a bunch of integers, right? So the first one, ABC 1, 2, 3, D, E, F, this is not allowed. And also for this guy, Alice Smith, I'm not sure this is, this is Alice, maybe. So she works -5 hours per week. So this is not allowed. And also for another Smith, so this guy doesn't have the first name. So I think this could be an issue. So these are the type of things that we want to reject when we are loading, when we are trying to insert them into the database. So the same thing happens with the department values. So XYZ, that obviously that's not good. And for department name, blah blah is not a legitimate department name. And for department mission, so department mission is a multi-valued attribute, and in this table it should require the department ID as well as the mission ID or the actual mission to be not null. So this is another thing that is problematic. And for works for, as you can see that in the works for table, we got TFN, which is the employee's primary key, and then we have I think the department ID. The second one is the department ID, and the third one is the number of hours or the fraction of hour, the number of hours they worked for the department, and obviously that cannot be null, and then the number of hours should not be negative. So, but the thing with our current schema is that if you look at it, it is a very basic one. It doesn't really specify any of the constraints we talked about, right? It only specified type of data, not really constraints on these data. So what happens when we're trying to load them? So I'm gonna do it this time. I'm gonna go do it in Linux. If we load the bad data in there, what do you think will happen? It will not reject these bad data. So let's try. Yeah, everything is inserted. Now our database is polluted. So this is not a very good thing. But in this exercise, we're going to repeatedly modify the constraints in the schema.sql so that we can prevent these bad tuples from being inserted when they are trying to be inserted into the database. So the next step is we need to add constraints to the schema so that we can shut these bad data out of the database. So what we can do is that, of course, you can delete these things one by one, but the easier way is you can connect to the database, and you can use the drop.sql. So this will drop all of the tables there, and now from this point, you can modify the schema and repeat this process. So we need to repeat the process of loading the schema, loading the good data, and then loading the bad data until the schema allows all of the good data into the database and prevents all bad data from being in the database. So how do we actually add constraints to the schema? So we talked about how to implement this. So basically, you need to read through section 5.5 of the PostgreSQL manual. So we got check constraints, not null constraints, unique constraints, things like that. So so this is the workflow. You need to create the database, load the schema, and then you need to investigate whether your schema actually prevent the bad data from being inserted in the database. And if it does not, you need to drop all of the tables and then do it again. So you need to do this over and over again until it prevents all bad data from being in the database. Let's just look at one of the examples that you could, I'm just going to show you one of the examples that you could prevent and you can figure the rest of them out by learning from PostgreSQL menu. So let's start by investigating. Okay, let's get out of the shell first, and let's just look at the bad data. Just look at the bad data and understand why they're bad. So first of all, let's look at this one. This is an easy one. So for employees table, right? The employees table, let's look at how employees table is defined initially. Initially, employees table, we are defining the TFN, the given name, the family name, the hours per week. The hours per week is a float, but we need the hours per week to be, you know, a reasonable number. So it should be between 0 and maybe 50 hours per week. So maybe it should be between 0 and 100. Let's just say that's the case. And also, for each of these tables, we need to understand what is their primary keys and what are the foreign keys that are connecting them. So for employee, it is obvious that the TFN is the primary key. For department, the department ID is the primary key. For department mission, the reason why we create a new table for department missions is because department missions is a multi-valued attribute, and the primary key of this department mission should be the combination of department ID as well as the keyword. And the department, and here department should be a foreign key referencing the department's ID. So basically, if we have a relational data model, this department should be referencing the ID in the department's table. And in the end, we have the works for table. In the works for table, this is modeling an end-to-end relationship. So basically, it stores the fraction of the time of the employee's week when they're working for different departments. So for this thing, the primary key is the combination of employee ID as well as department ID. So the employee here should reference the TFN in employees, and department should reference the ID in departments. And percentage, this will be an attribute associated with this relationship. So this fraction should obviously be between 0 and 1. So based on this analysis, maybe we can kind of modify it. So first we want to implement all of the primary keys. So how do we implement primary keys? So as you can see that the easiest way is that we can just put primary key here and after the attribute. So this is the easiest way. So I just put it here. For department, the primary key is department ID, put it here. And then what if we have like a combination of attributes as primary keys? In that case, we can put it in the end and then put them in brackets like this. So basically for department missions, the primary key is the combination of department and keyword. It's interesting. And for works for, based on the ER diagram, we know that the primary key should be the combination of employee and department. Yep. Department. Okay. Just in case there's a typo. And so now that we have implemented all primary keys, we need to look at foreign keys. So foreign keys are very important because we use foreign keys to connect tables together. So for employees, it should not have any foreign keys, right? Because all of these attributes are non-key attributes and TFN is the primary key. And for department, is the same thing. And for department missions, we should have a foreign key in here, because in here, the department is actually the same thing as the department ID. So here, this should reference one of the rows in the departments table, because we're recording the department missions. So how do we do that? We can just put references table column name in line. So this is the easiest way we can do that. So let's just do that here. So so basically, department references departments table, and it references the ID column. So that's how you declare a foreign key this way. And another way is you can do it in the end. So there are always two ways of declaring these keys. We can declare them in line, or we can declare them in the end. So here, this is fine, and keyword is not foreign key because it does not reference the primary key of another table. And for works for, how many foreign keys do we have in works for? Well, let me look at the ER diagram again. So we're modeling this relationship, works in or works for, whatever. We're modeling this relationship, and it actually is tied to two entities. So to correctly model this relationship, we need information. We need the primary key from employee, and we need primary key from department. So basically, we need two foreign keys referencing these primary keys. So the employee here should references employees table. Note that here we're doing it all in lower cases, because this is fine, it's all case insensitive. And for department, it references what? It references the same thing here. It references department's ID. Okay? It references department ID. And let me just stop here and try to load it and see if we made any mistakes. So let's connect to that. Let's just run drop again. Okay, we didn't have anything, so there's nothing to drop. And let's create these tables, and let's look at what we defined this time. So now you can see that we have defined this thing as a primary key, and TFN is the primary key, and then works for is a and then we have another thing, and we have another foreign key referencing our primary key here. So I think it's more interesting if we look at the structure of works for table. So works for, the primary key is the combination of employee and department, which is great, and then each of them is a foreign key referencing the primary key of another table. So department is referencing the department ID in departments, and employee is actually a foreign key referencing the TFN in employees table. So all looks good at this point. And what else do we need to do? We need to load some constraints. So let's just see at this point, can we prevent any of the bad data? So let's load the good data first. Okay, you see that now we are having some issues because it looks like we have some dependency issues. So after we have implemented the foreign keys and primary keys, now we have a violation of referential integrity. So right now it's basically saying that we're inserting a row of department missions. However, when we are entering department missions, we need to be able to assume that the department IDs and the department IDs are legitimate. And the same thing when we're entering entries in the works in table, we need to make sure that the employee's ID as well as the department's ID are both legitimate, meaning that they are already present in their own table. So the reason why we have this issue is because there are some dependencies of the data that we're inserting into the database. So let me show you by looking at so basically right here it shows the order in which we insert these data. So first we're inserting into department missions, and then we're inserting into department, and then we insert into employees, and then in the end we insert into works for. So if you remember the idea of referential integrity requires that whenever you're entering a value for a foreign key, it must be able to find a value in the table that it references. So basically, the reason why it went wrong is that in the beginning, the department table is empty, right? There's no admin department, there's no sales, there's no research. But now you're trying to insert department missions. So when they're inserting these, they're trying to check whether 001 department exists. They're trying to check whether 002 department exists. They're trying to check whether 003 department exists. And it turns out that these departments have not been created yet. So to get around this, we need to reorder the data, the insert statement, so that we can sort out the dependencies of the data. So obviously we should insert department and employees first, and then we should insert department missions and works for later. And between departments and employees, which one do you think we should insert first? Well, it really depends on whether they have dependencies or not, right? So let's look at our schema and see whether they really have dependencies. So this is our current schema. So department does not really, at this point, it doesn't really depend on the employees, but the employees does not really depend on departments. At this point, it's fine, but note that we're missing one. Note that here we're missing one relationship, right? So we got employee entity modeled as a table. We got department table. We got the multi-valued attribute table. We got works for table. There's one table that we're missing. We're missing the table for managers relationship. So remember that for every relationship, it can be modeled as a table, but whether or not we choose to have a separate table for it really depends on the cardinality as well as the participation constraints associated with this relationship. Let's just look at why did we create a separate table for works in. The reason why we created that is because this is a many-to-many relationship, and we have to create another table because we cannot have either employee or department creating a new foreign key pointing to the other table to present the works in relationship. But for managers, let's look at the cardinality here. So employee manages department. It looks like each department has a total participation, which means that each department needs to be managed by at least one employee. And here, employee, this is a one-to-many relationship, which means that each department should have exactly one manager, should have exactly one employee as the manager. And on the employee side, we see that employee has partial participation, which means that not all employees are managers, which makes sense. Like some of them are managers and some of them are not managers. And for each department, we have exactly one manager. And in this case, we can just use a foreign key to present the manager's relationship. What foreign key do you think we should put there? So we can either ask employees to store the department that they may or may not manage, or we can ask departments to store their manager's employee ID. Which one do you think makes more sense? We can think about this in a minute, and we can think about the case in real life. Well, most of the times, if you work for a company, on your employee record, do you see a column that is called "Do you happen to manage a department?" And if that's true, give me the department ID. We never seen that column because the majority of the employees are not managers. So makes more sense for the department to store the manager's ID. So in that case, in department, we have the manager column, right? So that's why in department we have the manager column. So manager column should be a foreign key that references the primary key of employees table. So basically this can also be called a manager's employee ID. So here we just call it manager. So what should we specify here? We should specify that this is a foreign key. So let's change that. And so basically manager, this is a foreign key, and maybe this time we write it in the end. Maybe this time we adopt this. We adopt another. Maybe this time we adopt the syntax where we write foreign keys in the end. Yeah, we can do that. So basically, the foreign key manager, manager references what? References employees. What do we reference? It references TFN, which is the primary key there. Okay, now that this is the last step in here, and let's look at the data.sql. So now between departments and employees, because department, they need to store the manager's employee ID. So before we insert into department, we need to insert the values for employees. So the correct order should be we insert into employees, and then we insert into departments, and then we insert into department missions, and then we insert into works for. Okay, so okay, let's look at whether we have implemented the foreign key manager correctly. So let's just drop all of the tables if they exist. Then let's load the schema.sql. See, looks like there's a syntax error with manager. Let's get back to schema to fix this. So it looks like manager needs parentheses as well, just like TFN. And let's load it again, and this. So what we're doing here, we're basically repeatedly loading it until we get it right. Okay, it looks like is right. Let me look at the department table. Here, manager is defining. Yes, the manager here is a foreign key referencing employees TFN. Great, which means that this relationship has been captured. And now let's load the data 0, which is basically the good data in the correct order. Everything looks good. And let's load the bad data and see whether they're prevented or not. So looks like we got rid of some bad data just by implementing the primary and foreign keys. And let's just look at the employees table looks like the first one, third one, and the fourth one are still not prevented. So let's examine the bad data. So as you can see that the first one is the TFN, the format is not going well, and the last two ones, the third one and the fourth one, they have issues because the number of hours should be between 0 and 7 times 24. So this is obviously too big, and -5 is obviously too small. So we're going to implement these constraints to prevent these tuples from being inserted, and you get the idea for the other tuples. And let's just do these. So the first one, this is a slightly difficult one because it requires pattern matching. You got to go to the pattern matching part of the PostgreSQL menu. There are many pattern matching. There are many ways to do pattern matching here, but we prefer the regular expression-based pattern matching, especially using the tilde operator. So basically, this will check whether the left-hand side text is matching the regular expression on the right. And here, the regular expression is pretty straightforward. The correct regular expression for TFN should be 3 integers dash 3 integers dash 3 integers. So we're going to implement that, and let's do that. So where do we put that? So we need to put the constraints in employees table. So what do we need to check? How do we do constraint checking? So basically what we do is that we're putting check and parentheses and things we actually want to check here. So basically we want to check whether TFN is of the format. So if you know regular expression, you should get this very quickly. So from 0 to 9 means digits, 3 means 3 digits, and all separated by dash. So we got all of these. And another check we want to do is we want to check the hours per week is larger than or equal to 0, and hours per week is less than or equal to 7 times 24. So we put column in here. For the last constraint, we don't put the column. We don't put the comma. Okay, this looks good. So this should prevent the first few bad tuples from being inserted. That's let's try again. So now let's try doing everything in Linux. So for a switch. So let's drop the tables. Let's do the schema again. Okay, looks like we have misspelled hours per week. Okay, this happens when we don't have a good text editor, so we always misspell things. Hours. My God, I cannot type anymore. Okay, let's do it again. So drop everything. Load the schema correctly loaded, load the correct data in the correct order, they're all done, and then we load, what do we load? We load the bad data and see if they're prevented. You can see that the first row fails because this does not pattern match the TFN pattern that we defined. And for -5 and 300, they also failed because they're not within the range of hours per week we specified. And so now we only have 3 bad tuples being inserted. So I will leave you to discover how to add more constraints to them. So basically, maybe you can just add more not-null constraints. You can add more range constraint so that you can correctly prevent all of these bad tuples from being inserted. And so everything you need is in the folder. So in the end, you should have, you can look at solution.sql, which is the final perfect schema that you have. Let's demonstrate that using the solution.sql, and you should get the same result as the solution.sql. So let's drop everything. Let's load solution.sql, which defines a bunch of tables, and then you should load the data in the correct order. And then we're loading the bad data. Everything should be rejected. Then this is good. Okay, so but obviously this exercise requires you to kind of read a little bit in PostgreSQL menu, but that is the expected workflow. So you're expected to learn a lot from the menu. And yeah, so if you've got any questions, feel free to post on the forum. Until next time, good luck.